Example number 3, we have an overall reaction and an experimentally determined rate law. Rate is equal to baby K times the concentration of NO2 times the concentration of fluorine, so both are first order. Here is a suggested mechanism, and is this an acceptable mechanism? Explain your reasoning. So there's 2 criteria in order to be a valid mechanism. Number 1, when we add the steps, we have to get the overall stoic, or the overall equation. So let's do that first. Let's add these together and see if we get the overall equation. Fluorines are going to cancel out. They are an intermediate. That's the only thing I see here that's going to cancel. So we are left with 2 NOs, fluorine, 2 NO2Fs. So check, yes. The sum of the steps equal the overall reaction. Okay, that's number 1, criteria number 1. Number 2, the rate law of the slow step must match the rate law of the overall equation. So if I examine our mechanism, our proposed mechanism, our slow step is the rate determining step. So when you're looking at a mechanism, locate the slow step, and then its rate law is going to be equal to that step plus any steps that appear above it, that come before it. Okay. Because that slow step is dependent upon anything happening before it. This happens to be the first step, so there's nothing there that the slow step is waiting on. So to write the rate law of a step, you are allowed to use the coefficients. So the rate is equal to baby K times the concentration of NO2, and its coefficient is a 1, so it's to the power of 1, times the concentration of F2, its coefficient is 1, so it's an order of 1. Remember, in our rate laws, we do not include products, it's only the reactants. And so this is the rate law of the slow step, the rate determining step. This must match the known rate law for the given equation. And you see here that they do match. You have the same rate law that is known to be for this reaction. So therefore, this is a valid mechanism because the rate law of the slow step matches the rate law of the overall reaction. So the rate law of the slow step matches the overall reaction rate law. This is criteria number 2 in order to be a valid mechanism. So the answer, is this acceptable mechanism? The answer is yes. Okay. Both criteria are met, and because I've already written this on my paper, I would get credit for just writing this along with criteria number 1 written out, sum of the steps equals the overall reaction, and criteria number 2, rate of the slow step matches the overall reaction rate law.